Hi guys, good afternoon. So in the last session, we saw about the floating static route. We saw about the null route and default route. So these two I gave you as a task, null and default. Any problems faced? Okay, same. Null route. Everybody?
Null route, sir.
Okay. So null I'll explain then. Let me go practically. Okay. Now take a look at this topology. So what do we have here? We have ISP, R1, and R2. These three routers are there. Okay. Between ISP and R1, we have a network 11.110/24. So here the IP is 11.1.110 and here the IP is 11.1.1.1. Okay. Then here between R1 and R2, we are running a network 172.168.1.0/24, right? And the IP is .1 and .2. This side, I have a network .3 running, and this side, I have a network that is .2 running. Okay. This is all of my internal network, right? This is entirely my internal network. Now, to reach all these networks, let's say on the ISP side, we have a route. Okay. So this side, I'll configure a route 172.16.0.0/16. Okay. There will be one route like this. Understood? On the R2, I will have a default route towards this side. Okay. On R2, I'll have a default route towards this side. On R1, I will have a default route towards the internet. Okay. And on R1, I will configure one route for the .3 also. I will configure one route for the .3 also for static. Okay. This is clear. When I'll do such things, what will happen? That now, if there is any traffic, let's say if there is a traffic for .1, .3, .2, that will reach specifically. But if there is any traffic, let's say on R2 or ISP, any side is trying to ping to 172.16.4. Now 4 is something that is not available. So this guy will use a default route. It will forward here. This guy will use the default route, forward to the internet. Internet will use the static route that will come back here. Okay. So let's see. Anyone is willing to configure? Hmm? You okay? Come here. You did last time, right? Then somebody else. Yes, who have not configured? Last person in the room. Then call him. You come here on the first seat. You guys sit. When I say sit, you could have shifted the chairs. Indra. Okay. Hmm? You're not? So you just need to write the configuration of a router. You just need to thorough with the router, not the UNG. No need to use a hash without hash. Router, ISP config. Okay, you write R1 configuration, fine. Loop back, 2 dot. Hmm? Okay, good. Who is going to do it for our ISP? Shift. Okay. Correct the first configuration, then start with ISP. Remove the hash. Hmm. Now start. Done. Okay. No? Why? You know. You also know. Yes. You don't know how to configure? Hmm? Confidence. Start. Play mission, not pipe.
Today is the 172.15.3.
Go back. Running code. Up. Nobody is careful about hostname. Huh? You will not be careful with the hostname, then in the production, you will stay confused because they will not be able to see the topology like this. Okay. You'll have to work on remote access. So make it a habit to give a host name. R1. Add. Now I have all the ISP also, R1 also, R2 also, right? Now, without null route, we know that there is going to be a loop, right? There is going to be a loop. Now, in static routing, how the loop is avoided? How do you avoid a loop in static route? Is the traffic going to loop forever? Or there is something to avoid loop? Hmm?
The minimum of 30 hops every day.
Hmm?
Minimum to 30 hops.
230 hops.
No, not 230.
30. Okay.
See that in place.
So that is trace route, right? That is different.
Okay.
Hmm? Host route. No. Null route is used to avoid a loop. But without null route, how the loop will be avoided? or it will never be avoided. How the TTL will go to zero after each hop. Hmm? Every time a packet is forwarded by a layer 3 device, the TTL reduces by 1. Okay. Okay. So what is the TTL value in case of Cisco? Hmm? TTL value for Cisco. Something, something. Hmm? What is the TTL value for Cisco? Louder. 255. For Windows? For Linux? 64. Depending on the operating system, we have TTL values. Cisco 255, Windows 128, Linux 64. Okay. Now all these three are configured routers. Now from here, I want to reach all these networks. Rather than defining three routes, I will define one route only. Right? So let's define IP route. Exit interface, big 0/0. Then next hop address, 11.1.1. Here, okay. In this case, in case of R1, so we will configure one default route towards the ISP and one route static for 3.0. Okay. IP route 3.0. Next stop will be 16.1.2 and exit interface V0/1. Done. And one default route I'll configure, that is towards the ISP. So my exit interface will be 0/0 and next stop will be 11.1.1. Right? Now R3, only one default route is required. V0/1 and next stop will be 16.1.1.1. Done. Okay. As of now, from ISP, if I will try to ping 3.2, you will be seeing that I'll be able to ping. Do ping 172.16.3.2, right? How many packets will drop? Hmm? How many packets will drop?
0.
Okay. One answer is 0. Anybody else?
One packet.
One packet. Now see here. 0 packet drop. Okay, and if you take a look at my packet capture, what do I have? Request, reply, request, reply, request, reply, request, reply, and request, reply. Right? Okay. Now we will restart the capture. Again, I'll go with ICMP. Now take a look. From here, I'll try to ping, let's say 5.2. What do you see? Do you see a loop? There is a loop. And here you can see the TTLs, right? So this will cause a loop. This will cause a loop. Okay, if you see here this message, okay, source is what? 11.1.10. Destination is 5.8. Okay, source is 11.1.10. Destination is, and here 11.10 is the source, 5.2 is the destination. So that means the packet is redirecting for the network. That means a loop is going on. Why? Because when I'm trying to ping from here, this guy is sending 4.2 here, this guy is sending back to. So there is a loop here. There is a loop here. So because there is this loop, we want that, okay, this loop has to be avoided. And how to avoid this loop? Null zero route. So let's go and configure the null zero. Okay. So here also we can check if I say like do debug IP packet detail. And if I try one more time, okay. So the packet is just coming back here. Okay. See, loop. Here. So to avoid this loop, we have the null zero route. Okay. So what we will do on here, on my edge, I'll configure a null zero route. Okay. I'll configure a null zero route. So what will happen? R1 will not forward the packet back to ISP. Okay. So let's go on R1 and I'll say IP route if there is any traffic for 172.16.0.0. This one I will send to null zero. Then you show IP route static. You can see I have this null zero route. And now if we capture the packets, so earlier we were getting this thing, redirect for network, right? Now we will not get it. Let me start the capture again. Now if I go and ping, what I get? So that means loop is not there. The loop has been avoided. Yes. In real also the same thing can happen. In real the things happen. That's why we have this concept to avoid the administrator mistakes, to avoid the loops. Because dynamic routing comes up with a loop avoidance mechanism. Static routing, there is no loop avoidance mechanism other than TTL value. But TTL also, if you go with the Cisco, if the traffic is generated from Cisco, so TTL value is 255. That means 255 hopes it has to travel. So like 1, 2, 3, 4, 5, 6. It will keep on looping, right? And that is just for one packet. Now imagine generating multiple packets. So you don't want that. Okay. This is clear now? Online people? Debug, you can read, see it. If you say, but I didn't understand anything. I saw, but I didn't understand anything like it's looping or not. There you will not understand the loop. There you will not, like in the debug, it will not tell you that whether or not there is a loop. There, that thing you have to see in the packet capture only. Okay. Or else if you are seeing in the debug, then you have to look at it carefully. Like you have to note down the ICMP type coming. Okay. So reply is never going to come. The request is keep on going. That means type 8. Okay, and another type you saw here, that was type 5, right? So if you take a look, ICMP type 5, which is for redirect. Okay, so we can take a look at the Wikipedia here. This is type 5. Okay, so it is redirected datagram for the network. That means the traffic is getting redirected. I'm sending, somebody sending me back. Again, I'm sending, somebody sending me back. This is okay. So either it is for a host or a network. Okay, and same thing for type of service and network, type of service and host. These are the codes. This is type, this is code. Okay, like we have ICMP type 8, but code is 0, then it is ACK request. Same way, type 0, code 0, it is ACK reply. But if we have ICMP type 3, now destination unreachable. Now this destination unreachable can have multiple reasons. Maybe the network, if network is unreachable, that means you are pinging a network and network is unreachable, 0. If a particular host is unreachable, 1. If a protocol is unreachable, 2. If a port is unreachable, 3, like that. So yes, you can take a look. Let's say, for example, okay, I closed it. Let me do one thing. I'll capture again. I'll capture again here. Here also, and in the debug also, you can have the same thing. See here. This is host unreachable. If I expand ICMP, type 3 code 1, what it says, host is unreachable. Clear? Okay. And the same thing you can take a look at it in the debug also. If you say do debug IP packet indicate, and if I try to ping now, so you can see my response is what? Type 3 code 1. I'm sending what? Type 8 code 0. But I'm receiving what? Type 3 code 1. Clear? So now clear? Now static route. Online people.
Yes.
Default route, I believe that is for sure clear. Hmm. Then there was a task for you, right? One more task was there, I remember. Hmm? Advantage and disadvantage of static route. Tell me. First of all, tell me about the advantage.
Within the high security environment to avoid dynamic updates.
Mm-hmm. Okay, so you say it is kind of secure. First point. Secure compared to dynamic routing. Yes.
Yes, so
Less bandwidth or less resource? Okay, so you say less bandwidth consumption And okay, then
We have a small routing table.
who says I can configure multiple routes?
Easy to implement in a small network.
Again, means more control.
Good. More administrative control.
More advanced knowledge. Easy to reconfigure.
Is it?
Reconfigure.
Is it? That is not a. When you apply condition in small network, dynamic routing is also simple.
Meant to say, you can trace the path.
So you can trace the path in dynamic also.
But if in dynamic, it's,
How do you trace a path? Tell me. Trace route. So in dynamic routing, you cannot use the trace route. Same utility. Router is going to forward the packet in the same way. Then anything else?
we use it as a backup of payload. So dynamic routing is we try to redirect the traffic.
Okay. And in what case your dynamic routing is not going to work?
If some link goes down,
So if link is down, static also can do anything.
we can have
Floating. So dynamic routing automatically calculates the best route, second best route.
that goes down.
How dynamic routing will go down?
Yes.
In case, see, it's not like just the one command is going to vanish that okay, no IP rep, no router rep, something like that. No. If link fails, static also can do anything. At least dynamic will do what dynamic will, let's say first link fails, dynamic will try to second path. If second also fails, dynamic will automatically try third path. In static, everything you have to configure manually. That is not an advantage. Troubleshooting is easy. Condition applied, small network. No. Then, so that is advantage. I can make it 100 also.
Low
Any other
CPU
item?
usage.
Sorry.
Lower CPU usage.
Okay, less resources. So tell me, first of all, how less bandwidth consumption? And before that, tell me how is it secure?
Because it is particularly different. We don't advertise it's not that
We don't
advertise
advertise packets. That means
no protocol.
no protocol is running. Good. How the less bandwidth consumption is there?
Updates packets. We don't send updates package.
If the protocol is not running, there will be no extra packets in the network. So obviously bandwidth consumption will be less. What about less resources? So there are less resource consumption. That means that if the protocol is not running, doesn't have to generate any extra packets, doesn't have to process any extra packets, right? So amount of resources are less. Okay. Then more administrator control is there because admin will decide what networks you communicate to and what networks you do not communicate. Okay. Now, how much memory a static route consumes? Hmm? 10%. 10%. And 10% of what? Total RAM. So that means if I will define 10 static route, 100% CPU or 100% RAM. How much memory? No idea. Let's see. Can we have this? Around 4200 bytes of memory. Okay. 4200. One answer I have. Let's check. Okay. Did you already Google? Hmm? Check on Google what Google says. How much memory a static route consumes?
You take only 2 bytes per route.
2 bytes, but how many bytes?
From 14 maximum.
Okay.
ChatGPT static route consumes 400 bytes.
Sorry.
Even if static route consumes 400 bytes.
400.
400.
2 to 400. Google or ChatGPT? ChatGPT. Check the comment. How do you check? What is the comment? Hmm?
Router can check
Yes, we can check.
declaration for static.
I'm talking about routing memory consumption. Okay. See here. So IP protocol. You see, we have some process like connected static and application. Okay. Summary only. to show IP route. Got it. Show IP route. Got it. So right now there is no route. Let's configure one. IP route. Next stop will be 12.2. My route is correct, right? Interface. Route is on interface. G0 by 0. Okay, you mean to say. Exactly. This is a global mode command. Okay. Now you can done. Do show IP protocol summary. No, not this command. So start like this. Show IP route summary. Now you can see. No. The command is different. It's not show IP protocol, it's show IP route summary. So you see here one static route or one route entry in my routing table is consuming how much memory? 180 bytes of memory. Okay. So right now, what is the total memory consumption? It is 1180 bytes. Why I have two subnets here? Because if you take a look, one is my network and one route for local, connected and local, right? Two directly connected routes are there. So that is the reason here it is. Okay. And here it is 180. This is clear. Then for some internal routes, it is using 640 bytes of memory. If you enable, let's say, routing, if I say configure terminal, and if I say router rep, now this protocol is also running. Do show IP route summary. Okay. Okay, still not because I haven't given a route here. So let's say I'll give a network and my network is 192.168.12.0. Done. But still in my routing table, there is no rep route. Okay. You can see there is no route because R2 will send it to the R1. So let's go and configure this on R1 also. Router rep network 192.168.12.0. Then network 10.1.1. There. Done. Now let's take a look. Wait for it, the route will come in some time. So not important. Interface is okay. Interface is wrong here. That's all. Okay. Default interface is 0/1. Interface 0 by 0. Not like that. Now we will have a route. Once the interface will come up, routing protocol will start, then we will have a route. Fine. Here it is 12.0 to show run. Section, right? I think network is okay. Network is 12.0 here. Okay, what is the interface name here? R1 is okay. This is 12.0 and this is has to be in the same network. To show IP interface brief 12.1. 12.2. 0 by 0, 0 by 0. Interfaces are up, all good. Now we have the route. Okay, so now we can check. To show IP route summary. So you can see even a dynamic route is containing what? Same amount of memory. Is that clear? So that means one entry in the routing table. One entry in the routing table consumes 180 bytes of memory. Which one? Because we configured the IP on the wrong interface. So I set this interface to its default configuration. Okay. So by default, there is no IP address. So that means all the configuration from the interface will be removed. No configuration is there on that particular interface. Okay. Online people, this is clear. So if you want to check, on a router, one route entry in the routing table consumes 180 bytes of memory. Okay. Check the memory consumption. You can use the command. So IP route summary. Here. Now the next thing. Disadvantage. Tell me. Large networks. Number one. Let's be simple. Cannot be used for large. When you must have the idea of there is no metric used at all. So you cannot talk about metric change. Okay.
There's a chances of misconfigurations.
All right. Chances of misconfigurations. Okay. So I'll say prone to misconfiguration. Okay, you might end up configuring a wrong IP in the network, right? Not scalable because we cannot use it in the last network. Simple. This is clear? Hmm? Why no fault tolerance? You configure floating static route. Why? For fault tolerance only, right? So you can say here more administrative overhead. That means everything to be configured manually by the admin only, whether to add the routes, remove the routes. Okay. Okay. And
Proper knowledge of topology and each network.
correct. So you can say proper knowledge of topology required. Then you can configure it only if your destination networks are known. We can't do load balance. Who says we cannot do load balancing? If you configure two routes, it will start doing load balancing. Okay. So proper knowledge of the topology required, more administrative overhead, prone to misconfiguration, cannot be used for large networks. Okay. And I think I just said one point I forgot. What was the point? Okay. I'll write when I'll remember. Anything else you have in mind?
Destination is remember.
Yeah, destination part. Okay. So in this case, destination networks must be known. If you don't know about destination, you cannot configure static route. Clear? These are the disadvantages. Now we'll talk about difference between static and dynamic route. Default is a case, right? But we are talking about static. Let's say if you want to configure a static route, in that case, what? Your destination networks must be known. And more than one default route you cannot configure on a router. Otherwise, you will have packet drop. Okay. Note it.
Sir, floating static route is for redundancy purpose, right?
Yeah, redundancy, correct.
Can we use a default route for suppose two ISP needs to configure? That we can do now for the default route as well.
Yeah, you can do that.
Okay.
Your default route also you can configure as a floating because typo is what? Static only.
Okay, fine.
Okay. So even your default route, you can configure it as a floating.
Okay.
That means one will have a AD value of 1, another one will have a AD value of 10.
So one ISP is down, automatically all users can access other ISP, right?
Correct. But in that, sometimes there are issues that if the problem is from the ISP side, then your static routing cannot do anything. Even your default route will not do anything. Your router will start forwarding traffic to the primary one, even if primary is down. Okay,
even
so
it is primary is down, it already always forward to primary side.
yes. And for that reason, we will study one concept in the end of our batch, which is about IPSL. Okay.
Okay.
To recover from that kind of ISP side errors only.
Okay.
Okay. Okay. Now, difference between static and dynamic route. static and dynamic. So tell me. What is the difference? Enterprise. First of all, or we will say like not manual configuration, dynamic also you configure, right? It doesn't get configured automatically. But here instead we will say routes are added manually. In case of static, the routes are added manually. Then what about dynamic? Routes are added, let's say automatically. Okay. The help of dynamic routing protocol. Then
Memory usage in static is low and high in dynamic.
memory usage in static is low. Okay, or we will say less resource consumption, same thing. Basically, memory will be used almost equally. Less resource consumption, more resource consumption. Then here you can say less bandwidth consumption. Here, more bandwidth consumption. Then what else?
Scalability.
Low scalability. Okay, and high scalability. Okay, then if I let's say if I discuss about the protocol rep and the dynamic and static, then who has more scalability? Right? Because static you can keep on configuring after 15 routers also, and it will work very fine. While RIP cannot communicate beyond 15 hops. Right? Okay. Anything else? Secure. Okay. More secure. So this is what? Less secure. How it is more secure and less secure? So
The routing updates can be attacked.
correct. The routing updates, they can be captured and they can be seen. That what is the information traveling in them, right? So here we can say less secure. Okay. Anything else?
The link gets failed, we won't get update. If the link gets failed now, we won't get automatic update.
No automatic fault tolerance. Okay. Here we will say new route calculated automatic. Then destination must be known. And here destination is, let's say, automatic. We don't have to manually give the destination. We don't need to know about the destination. The routers will communicate with each other and they will know about the destination. Okay.
Load balancing.
Load balancing available in static also. Okay. We can configure two static routes and they will start doing load balancing. You can keep on adding points. Okay. But these are some of the common points. Now, in dynamic routing, we have different types. IGP, EGP, correct? Noted this thing? Hmm? Hmm? Note it down quick. If you will not make notes, I'll stop creating these also. I'll stop sharing. Because the more you use pen and paper, the more you remember. See, I have the same picture from the last batch also. I can use that one also. Why should I create a new one? And I can share with you the same thing. That will save us a lot of work. But still, I'm doing it over and over again. Why? It helps me to remember. So you should try the same thing. How many of you are honestly going through these paint files? And once the batch completes, then after that, how many times you check the CCNA videos? How many times you check? Hmm? Let's say right now you are going with the routing. Do you check CCNA videos or the notes? No. Very rarely somebody will pick. Then when you will study switching, you will forget about routing. When you will study advanced, you will forget about switching. Then further you will go, some people will go in the security, they will study ASA FTD, they will forget everything. Why? Because we don't practice. Simple. Got it? You should have a habit of practice. How many hours you spend on practice every day? 2 hours. Okay. 4 hours. Next one, 6 hours. Hmm? 10 hours. Don't include the time you're sitting here. Hmm? How much time? Hmm? 0 minutes. I think you have enough time every day to practice. But then we have movies, series, right? Netflix. Okay, so this is done. So we have IGP. I think this discussion we had already had. Then EGP. So just you will be telling me quick difference. Same as communication. This is for different AS communication. I think I have it in this one only in this copy. This same paint file on there. If I have it. Okay, so this is about dynamic routing. Dynamic, the routes are dynamically learned via the help of routing protocols. So we have two types, interior gateway protocol and exterior gateway protocol. Your interior gateway protocol provides same AS communication, while exterior gateway protocol provides different AS communication, right? Then IGP is further divided into three categories: distance vector, link state, and hybrid. Distance vector focus on the distance between source and destination, okay, while link state focuses on the bandwidth, and hybrid focuses on the both the things. It has features of both, right? Distance vector protocols like RIP and IGRP. Link state protocols, OSPF and ISIS, and hybrid protocol is EIGRP, right? And then under EGP, we have only one category, path vector, and only one protocol, BGP. And before BGP, EGP itself was a protocol. Okay. This is clear? Okay. Now, first of all, we will go with the distance vector. That means the protocol. All right. Let's see what you know about this protocol. You studied in CCNA, I believe. As the name suggests, this protocol, rest in peace. Obsolete, right? Okay. So tell me what do you know about this protocol? Directly, Maxwell. Okay. Number one,
Maximum 15 hops.
first of all, this is the distance vector protocol. Yeah. Distance vector protocol. Then, okay, it's a layer 7 protocol. Then, okay, uses UDP service. But first of all, if you're telling it's based on UDP, at least tell me port number.
520.
520. Correct. Okay. Uses port number. Okay. What is the protocol number? What is the protocol number?
17.
70. Who was saying it about application layer? What about application layer? Then how does HTTP have a protocol number? Services of TCP. So that means if the communication is happening over TCP, the protocol number will be okay. Yeah. Okay. Then what is the ICMP protocol number?
1.
And port number? What is the IP port number? IP layer 3 protocol, how come it will have a port number? Okay. So it uses port number 520 UDP. Then, so first of all, at least you will explain, right? It has two versions. Okay. Huh?
It has two versions, version 1 and 2.
It uses bandwidth and Bellman-Ford algorithm. Good. Okay. Uses Bellman-Ford distance vector algorithm. AD value?
AD value 120.
AD value of is 120. Then maximum hop count limit is 15. Then timers? No, not here. Okay, it has two versions. So, okay, now let's talk about the differences. Now, tell me the differences. Does not support CADF. Okay. So simply say this is class 4. Supports class 4 routing. Classless routing. Then broadcast routing updates. Here routing updates are multi-class. Then what is the broadcast address? Broadcast address. You studied. That's why I am asking. You didn't study. Hmm? Is it? You have my video, right? We'll get to it. Nobody studied about the address.
224.0.0.9.
Broadcast, guys.
255.255.255.255.255.
Universal broadcast address it uses. And this one uses multicast address
224.0.0.9.
009. Then anything else?
No subnet mask.
Subnet mask classful. We already said. Okay.
Works only on version 1.
Works only on version 1. So how is it a difference in version 1?
Version 2 works on both version 1 and version 2.
Okay. So you can say backward compatibility, right? That version 2 is compatible. So version 1 doesn't have a version previously. So how compatible?
Version 1 not supported VLSM.
Again, this is classful, but still let me mention it. You're saying again and again. So no,
Version 1 does not support authentication.
good. This was an important point.
Yeah.
Okay. So this one does not support authentication. Very important. While this supports authentication. Okay. Clear? So these are the differences. Then you can say which sense periodic updates. Okay. The updates are sent every 30 seconds by default. Okay. Then this includes full routing table. In
For
the
update method, version 1 broadcast and version 2 multicast.
that is already we have mentioned in the differences, right? And it includes full routing table in the routing update. Clear? Okay. Now, maximum of how many routes can be there in a update? Okay, that I will show you practically. You haven't studied that. This thing is clear so far? Okay, then let's talk about the basic configuration. Okay, let's say you have R1, you have R2, this is 0 by 0. This is 12.1. This is 12.2. This is R1. This one is R2. And we are going to configure it here. And let's say, for example, this side I'll use few loopbacks 10.1.1.1/24. Then let's say 20.1.1.1 /24. 30.1.1.1 /24. 41.1.1 /24. 31.1.1 last. Okay. 37. Now let's say I have to configure it. So first of all, if I need to configure version 1 and 2, there are not much of a difference. Okay. So let's say you have to configure it on R1. So how will you configure it? Okay. Interface. IP routing.
Router RIP.
You said everything except the correct word.
Then version.
Version we can say. So you can say version 1 or version 2. Okay. By default, it is version 1 or version 2. Note down this question. What is the default RIP version? I'll show you. That's why I'm asking. There is something I need to tell you. Okay. Then network and network address. Correct. That's it. We don't give the subnet mask or anything. Anything
Yes.
else? That's it. Something missing? Hmm? No, sir.
No to summary.
Good. No. This is also a command. Why we use it?
And if you have the flag value of 24, there will be receiving the flag value of the space. So if you don't use the command no auto summary, they automatically receive the flag value.
And how will you explain it? By default, doesn't matter whether it's version 1 or 2. Version 1 already classful. But even version 2, by default, it will summarize all your networks to the classful boundary. By default, RIP summarizes the networks to its classful boundaries. So that means all the loopbacks, they will be changed into /8. Is that clear? So we don't want RIP to summarize all the networks. We don't want it to, make it in the classful boundaries. In that case, you use no auto sum. Okay. No auto sum. Clear? So this thing here, okay. What is this? What kind of network ID? This network ID that you're going to give here is going to be a directly connected network. In static routing, we always define the destination. While in dynamic routing, we define what? We define only the directly connected networks. Right? This is clear? Okay. Now back to the question. What is the default rip version? How can you say version 1? Because you type the command version 2. What is the default rip version? Version 2. Because I'm asking question on version 1. Then
Version 1 I have only the specifications of version 1. But version 2 we have both the specification of version 1 and version 2.
okay.
So default will be version. Even null shown with you not yet version. For configuring array things. You are not doing that version. So increase the version.
Now version 1 or version 2? Interesting, right? Check. Show IP protocol. See here. Read this thing and you will get to know. By default, a router will send routing update for version 1 only, but while receiving, it will receive for both the versions. Version 1 also, version 2 also. Because version 2 is also backward compatible with version. Understood? Now, default version. So when you are asked about default version, you can explain this thing. That by default, a router configured with RIP sends routing update for version 1 and receives routing update for version 1 as well as version 2. Understood? Note this down, you'll forget. Note down. Oh, you will go through the video again. By default, a router configured with RIP sends routing update for version 1 and receives routing update for both version 1 and version 2. Receives routing update for both version 1 and version 2. Okay. This is how you prepare interview question. Understood? Okay. Then here itself, you can also see this thing that what is the default AD value? Default AD value is 120, right? Then how frequently the updates are being sent? Every 30 seconds. And the next update is due in 90 seconds. This is the invalid timer. 180 seconds, hold down timer, 180 seconds, and flush timer, 240 seconds. Clear? Online people?
Yes, sir. Clear.
Okay. So although you know about the RIP protocol, still there are few things I need to tell. So those only things I will explain, remaining you can practice. Okay. Like how to configure RIP, so you know how to configure. So this is one thing we have configured. And you see, I didn't use the no auto summary command. Okay. So note down the use of this command also. Now, by default, RIP summarizes the networks to their classical boundaries. to disable auto summarization. Okay, to disable auto summarization, we use no auto summary comment. Yeah. And then by default, a router configured with send routing update for version 1 and repeats routing updates for version 1 and version 2. Yeah. So whatever the commands you execute, you must know what is the meaning. Okay. All right. This is clear. Now, see here. So I didn't use the no auto summary command. That's why what is happening here. So IP route rip. So you can see I'm getting what? Flash 8. Now I'll go here. I'll say router. Good. And then I'll say no auto summary. Okay, the full command is no auto summary. Okay. Now, if I have given no auto summary, now you'll see two routes. If I execute the command. Okay, I think no. Wait for it. Okay, still I'm not getting why. Let's see who can tell me why I'm not getting it. Because by default, sending updates for version 1 only, and version 1 updates do not include subnet mask information. Okay, so let me just go with the auto summary again. Okay, and I will change the version to 2. Okay, so still there will be no difference at all. Okay, how do you know that the version has changed or not? So let's say I will say no version 1 or no version 2. Back to default. What we can do, I can go here and I can say debug IP packet. You see UDP source port, destination port information is there, right? And see here, source is 12.2, destination is universal broadcast. That means this is an update for version 1. This is clear. And as soon as I'll go here and give version 2. Okay. Now the next update you will see here after 30 seconds. You see, what is the destination? This time the destination is 224009. Clear? Okay. So that means version change is confirmed. But still, if I check do show IP route, okay. Oh, sorry, show IP route. Okay. So still I do have what? /8 on. I'm not getting /24. Okay. So now what to do? I'll say no auto summary. And now you will see that I'll get a route with the 24. Once the update will be here, then I'll get it. Update is there, right? And show IP route rep. Wait for it. The update should be there. Mask page. Have another update. So IP route. Okay, because I have configured a static route, that's why it is creating issues. To run the route. So now you will see don't show IP route. Because so far the route was discarded. Okay, so we have a rip route. Now you can see both the routes. Right? But I have two routes. Why? Why do I have two routes here? I have only one network, one protocol running. Then why do I have two routes? Version 1 and version 2. No. If you check, do show IP. Okay. Let me do one thing. Router version 2. Okay. So now you can see still there will be two routes only. And if you check do show IP protocol, you can see sending version 2, receiving also version 2 only. Then what? What is the problem? Why do I have two routes? The reason is because of this invalid timer 180 second, hold down timer 180 second. That means 1 minute, how much? 3 minutes. This is also 3 minutes. Then after 60 seconds, that means 4 minutes. And you see, already so much time has happened. That's why it says this is possibly down. That means this route has been declared invalid. This route has been declared invalid. And after 4 minutes, this will be removed. The total time your rip takes is around 6 to 7 minutes. You can modify timers, we can modify. Okay, but still it takes a lot of time. It's a slow protocol. Okay, and you see the the route has been flushed from the routing table. Is that clear? Okay. Then second thing I was telling you that, in version 1, RIP do not include the subnet mask information. So how do we verify it? I'll just go and capture the interface. Filter the. Let's wait for an update. This is an update. Okay, so if I go and take a look at this update, you see it includes the information about that there is a network and subnet mask. If I change it to version 1 on R2, if I go and say, okay, let me change this. This is also version 1 and this is also version 2. Now when the 12.2 will send an update, first of all, destination IP address will be 4 times 255. And we will see that there will be no subnet mask information. Okay, if I expand the routing information protocol and IP address, as of now, I see the subnet mask information. Do you see which version? 1. Select this one, expand it. In the IP address, you have only IP address information. There is no subnet mask information. So in version 1 updates, subnet mask information is not included, while in version 2 updates, subnet mask information is included. Is that clear? And that's why it is supporting classless routing. Understood? Online people clear?
Yes, sir.
Yes.
So more about RIP will be tomorrow. Okay. And probably tomorrow we'll start with the Agile. Okay. All right. So that's it for the day, guys. I'll see you guys tomorrow. Have a good day. If any doubt,
Thank,
you can ask.
thank you, sir. Sir, in routing table, the chronological order is there for checking one by one. First AD value and prefix like that. I have some confusions. And you can please tell me the order.
Like where? Just first
No, no.
AD value will be checked, right?
First AD
Routing,
value,
first
right?
of all, in the routing table, only your best routes will be added. That
Okay.
means the routes with the least AD, least matrix.
Okay.
Okay. So only your routes through which your router is going to forward the traffic, those routes will be available in the routing table. Other routes will never be there. Routing table.
Okay.
Okay. And while preferring, router will first check the AD value to compare the routes and protocols.
If
Then-
AD value is tie,
Then metric it will check.
metric.
Okay. That means you can simply say first it will check this part, and then after that it will check this part.
Okay. Okay.
Okay.
Metric. Okay. Metric
Now,
and AD value.
when for the same network, multiple routes are there. For the same network, multiple routes are there. Then it will check the longest preference. Okay.
While finding the IP address, you can assign the subnet mask also, version 1, but it will not accept.
Which one?
Which one?
Version 1 IP address is a different thing, right? Okay, while configuring RIP version 1 or version 2, you do not mention subnet mask in the network statement. It doesn't make a difference. On the interface, when you configure IP address, you will always have to configure subnet mask. That thing you cannot change.
It does not understand.
No, it's not about understanding. It does not include the information. Okay. Any other doubts? No.
Sir, the AD value and metric both are tie. Then next day.
Then load balancing.
Okay. Okay. Thank you.
All right then. I'll see you guys tomorrow. Have a good day.